Hello folks, we come to the new exercise 4.3, and this is our part 1 video. And here what we are going to do is they will give us the coordinates of triangle. That means 3 coordinates will be given to us. We have to find the area of the triangle. Now this is nothing new to us. We have done this in the 10th standard in the coordinate geometry chapter, where we used to have a ready-made formula and we used to use that to do our work. I hope you remember that area of the triangle formula we had in the 10th standard: half times x1 into y2 minus y3 plus x2 times y3 minus y2 plus x3 times y1 minus y2. Or I think there is a minus. I'm not very sure about this formula, but something like this we have done in the 10th standard. The same thing we are going to do over here, but only relaxation over here is that because we are in the determinants, we know the properties of the determinants. You can simplify the determinants and simplified value you can get. Not like here that elaborately you need not do. You will be able to get the simplified version of it. 1 minute, I will just confirm the formula. No, it's not good to leave it halfway. Half times, yeah, it is plus x2. Plus only. Yes. Okay, so this is what we studied in the 10th standard. Its counterpart we are learning in the 12th standard. Only the advantage is that because we know the properties of determinants, we are able to modify and simplify and then do your work. Now, and simplification, it's not necessary that every time we will require. Sometimes we will require it, sometimes we will not require it. If you don't require, there's no need to infuse the property and do it. You can do it directly also. So what we understand over here, that we are given a triangle ABC whose coordinates are, suppose if we plan to call them like this, these are the coordinates, then we have to find its area. Okay, it's your wish. You want to call it by that name, you can call it like that, otherwise you can write directly area of the triangle. Therefore, area of this triangle ABC, because we have called it, otherwise you can say area of the triangle is half times determinant. Actually, formula wise it's x1 y1 1, sorry, x2 y2 1, x3 y3 1. That's a formula. So here it is half times 1 0 1 6 0 1, then 4 3 1. See, actually what happens is there are many zeros here. Directly you can expand and get the answer, but sometimes what we do is, because of these ones, they serve as an advantage to us. We try to get zeros there, and then from there we expand the determinant. The determinant expansion becomes easier. It's not so elaborate. So since we know now the properties, we'll do that like that rather than sitting and elaborating. So what we'll do, at one shot we'll get a zero here at these two places. We have learned to do it at one shot. We are operating R2 as R2 minus R1, and we are also operating R3 as R3 minus R1. What is the advantage? Minus 1, this is of a 0, minus 1, 0, minus 0 actually, and then minus 1. So you are going to get this as half times 1 0 1 will stay as it is, 6 minus 1 will become 5, 0 0, 3 3 and 0. So many zeros have come. So expanding becomes easier. Now we'll go in for the expansion. How do we expand? One time. This is 0, this is 0, fully 0, and this is 0, so then you need not write it. Then 1 times 5 into 3, 15 minus 0 again. So it's like half times 0 0, and only 15 is left. Half times 15, 7.5 square units. Understood? So that's the area of that given triangle. So same way, as every time that's the coordinates are given, you can call it by some name and do it, or you can just write in general area of the triangle. If you want to use the properties, you can use the property. If you feel that's no need to use the property, you can get it directly. If you want to do it like that, that's totally your wish. Its only thing is that since we know the properties, if we want, we can use it. Luckily here in the exercise we don't see much big problems. Suppose if the digits are big, then sometimes it's easier to use the properties. So here, like before, if you want to call them by vertices, or you can call area of the triangle directly half times. Look at the problem and look at how it is. If it's a huge problem with quite a lot of marks, write the formula x1 y1 1 by x2 y2 1. If it's okay, 1 mark problem also, then you can directly get across doing the problem. 2 7 1 1 1 1 10 8 1. Okay, so like before, we will use the properties, because we are beginners. It's better we use the property. We'll get more used to the properties, right? So we are going to use the property R2 becoming R2 minus R1, but we are doing it at one shot. Actually, you can take 2 steps and do it, but it's actually not necessary. It's easy. You can do it at one step. See, this is minus 2, minus 7, minus 1. Minus 2, minus 7, minus 1. 2, 7, 1 as it is. 1 minus 2, minus 1, minus 6, 0, 8, 1 and 0. So let's see how to expand this. Half times 2 into, it's going to be 0. 7 times 0. 1 time minus 1, minus 48, it's not minus 48, plus 48. So it's 47. Net effect 47 by 2. You keep it like that, or you can maybe 23.5 square units. Right? That's it. Not much of work. Then area of the triangle again here. You have to find its half times minus 2, minus 3, 1. Then it's 3, 2 and 1. It's minus 1, minus 8, 1. Now such type of problems, it's better you use the properties, because so many minuses and so many big digits and all that, it's good that you use the properties. Our all-time strategy is this. So we are going to use that strategy. And what is this? This is minus 2, so plus 2, plus 3, then minus 1. Minus 1, plus 3, then plus 2. So what is coming? Area of the triangle is becoming half times minus 2, minus 3, 1 will stay as it is. This is 5 and this is 5, but this is 0. This is 1, right? And this is minus 5 and this is 0. So if you wish, you can take the 5 out of R2, because 5 is common. And if you wish, you can take it out. So you will get 5 by 2 times minus 2, minus 3, 1, 1, 1, 0, 1, minus 5, 0. Now let's expand. 5 by 2 times minus 2 will be 0, minus 3 also will be 0, minus 3, so minus 6 plus 3, because in between that unit will become minus. We haven't noticed that much. Yeah. Then last entry 1. 1 time it's minus 5 minus 1, so minus 6. So it's like 5 by 2 into minus 6. So it's like minus 3. Now actually the answer is coming as minus 15 square units, but because area cannot be negative, we'll always take the modulus of it. So minus 15. Therefore area of the triangle, we are taking the modulus, is 15 square units. Yeah. Next question is, they give us the coordinates A, B and C. They give us 3 points A, B, C. They give its coordinates and they ask us to show that it's collinear. Now there's nothing new to us. We have learnt it in the 10th standard also. In order to show collinearity, what we will do is, we will show that the area of the triangle is 0. Whenever the area of the triangle is 0, it always means that the 3 points are collinear, because it's no longer a triangle, it gets flattened to a line. That's the meaning when it is collinear. So therefore, if you show that the area of the triangle is 0, it's as good as showing that it's collinear. So they have asked us to show the collinearity, means we have to show that the area of the triangle is 0. So we start with the area of the triangle. So consider, okay, first step, let's consider the area of the triangle ABC. We all know that it's half times. No need to write the formula. As I said, depending on the problem's scope, you have to write. But this is because we are beginners, we write 10 times and we'll get used to the formula, that's it. Now, see, as I said, the advantage of taking this determinant doing it is that we are able to use the properties of determinants. So we could use the property of determinant over here, like we could have this C2 added to C1. What is the advantage? That the entire C1 column will become the same. It will be the same entry, and the same entry will go out of the determinant. Then you will get 2 columns identical, and then the determinant value will become 0. So that's how you will be able to proceed. Let's see, we are operating C1 by C1 plus C2. So you are getting this as half times A plus B plus C, B plus C plus A, C plus A plus B. Net effect, it is A plus B plus C only. B plus C, C plus A plus B, 1, 1, 1. Now So because it's a plus b plus c throughout, I am taking it out of the determinant from column 1. So where we are getting 1 1 1 left, b plus c plus a plus b, 1 1 1. There are two columns which are identical. Whenever you have two rows or two columns identical in a determinant, the determinant value becomes 0. So like that, this will become a plus b plus c by 2 into 0. Value is 0. Get the answer as 0. Now, okay, so you're getting the value as 0. Now, what has happened? Area of the triangle ABC, therefore it's like area of the triangle ABC is 0, but that's not what they have asked you. They have asked you collinearity. So therefore, A, B, C are collinear. The conclusion is very important because this is not what they have asked you. This is what they have asked you. So you have to conclude, otherwise you tend to lose marks there. Right? That's about it. Very light and very easy to handle. So we have some more problems of this nature that we are taking it up in the next video. Thank you.